Hello my dear students and my dear friends. We are in the chapter Permutation and Combination and we are in the exercise 6.2. This is the second part of exercise 6.2. Now in this part, let us start from question number 8. Let us read the question. In how many ways 5 boys and 6 girls can be seated in a long bench so that each boy will sit between 2 girls? Okay, here you see number of girls are more. So how one arrangement can be done, you see. Now as there are more number of girls, so let us write the girls at first. 6 girls, 1 2 3 4 5 6 girls. Okay, now this 6 girl can be arranged in factorial 6 ways, because this girl can come here, this girl can go this here or here or here or here. In this way, this 6 girl can be arranged in factorial 6 ways. Now there are 5 boys. Here condition is that each boy will sit between 2 girls. Between two girls, the boy will sit. Now these boys can be arranged. You see, this boy can sit here, this boy can sit here, this boy can go there, this boy can go there, or this boy can go there. Similarly, for all the other boys, it is applicable. Now these five boys can be arranged in factorial 5 ways. You see, earlier we discussed that the 6 girls can be arranged in how many ways? Factorial 6 ways, and the 5 boys can be arranged in factorial 5 ways. So what is the total number of arrangement? Total number of arrangement is factorial 6 into factorial 5. That is our answer. So let us write down. 6 girls can be arranged in factorial 6 ways. 5 boys can be arranged factorial 5 ways. So the total number of arrangement what we will do? We shall just multiply, isn't it? Factorial 6 into factorial 5. This is factorial 6 can be arranged in how many ways? 6 into 5 into 4 into 3 into 2. No need to write 1. This 5 again can be written as 5 into 4 into 3 into 2 into 1. We will not write. Now it is just like this. 6, there is 2 5, so 25. There are 2 4, so it is 16. This is 2 3 3 is 9, 2 2 is 4. So let us multiply. Now 16 into 9, we know it is 144, and into 6, eight 6 4, then 25 into 4 is 100. So if we multiply, it is 0. So total number of arrangement is 86,400. Okay, now we have taken question number 9. Let us read the question. How many words can be formed with the letters of the word pencil, pencil, begin with C? If it begins with C, then let us see how it look like. One arrangement, just we are observing pen, this C we have written IL. Now this place is fixed. Okay, here you see how many letters are there, or alphabets are there. 1 2 3 4 5 6. But out of 6, this position is fixed, because according to the question, all the words will begin with C. So this position is fixed. We have to arrange the remaining 5 letters. You see, there are 5 letters. 1 2 3 4 5. So let us write it here. In this case, the remaining 5 letters can be arranged in factorial 5 ways. That is, now factorial 5 ways means how many? 5 into 4 into 3 into 2 into 1. So this is 4 3 is 12 and 5 2 is 10. So 120 ways. Okay, now dear students, let us see question number 10. We have taken question number 10. Here it is, how many ways the letter of the word rubber, R-U-B-B-E-R, can be arranged. Now there a conception is required. Let us explain that. Suppose a word begins like this: A, B, 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 C, D, like this. Okay, here to understand in the simplest way, we have taken these letters are together. Okay, now what is the total number of arrangement? Here let us count how many letters are there. Total number of letters: 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 9 letters can be arranged in factorial 9 ways. But among these A and among these B, how they will be arranged? So what is the total number of arrangement? I am writing here. In this concept we shall solve it. Here we have to divide the total number of arrangement by this number, that is factorial. Here number of A is 3, so we will divide by factorial 3. Again, this B is, how many B's are there? 1, 2, 3, 4. So this can also be arranged in factorial 4 ways. So what is the procedure to solve it? At first we shall write the total number of letters, the factorial of that, and the factorial of these alphabets which are repeated. There are 3A, factorial 3 ways. There are 4B, so again this is divided by factorial 4 ways. Okay, now let us see here. The total number of arrangement will be, you see here how many letters are there. Let us count: 1, 2, 3, 4, 5, 6. So factorial 6 divided by, then let us see, is anything repeated? Yes, R are repeated twice, so this is factorial 2. Here what was A was repeated 3 times, so divided by factorial 3. R is repeated 2 times, so factorial 2. Again, any other letter repeated? Yes, this B is repeated twice, so into factorial 2. Okay, everything whatever is repeated, that one will divide, and among them we shall multiply here, that is factorial 2 into factorial 2. Let us simplify. This factorial 6 can be written as 6 into 5 into 4 into 3 into 2. No need to write that one, you can write, that is not a problem. Factorial 2 means 2 into 1, we shall write 2 because 2 into 1 is 2. Again this factorial 2 is 2 into 1, we shall write 2. 2 2 is 4, this 4 is cancelled. Okay, now 5 2 is 10, 6 3 is 18, 18 into 10, 180. So in 180 ways we can do this. Okay. Now my beloved students, we have taken question number 11. Let us read the question. How many words not ending with W can be formed with the letters of the word flower, F-L-O-W-E-R? Now, if there is no condition, how many ways these letters can be arranged? Here there is a condition, the words cannot end with W. But let us suppose that there is no condition, only in how many ways these letters can be arranged. Let us see. At first we have to know how many letters are there. 1, 2, 3, 4, 5, 6. So there are 6 letters. These 6 letters can be arranged in how many ways? Factorial 6 ways. Right. The 6 letters can be arranged in factorial 6 ways. Now here it is given that the words not ending. If anything is given not ending, not starting, what we do? We take the opposite, that means ending with or starting with. Now let us see the number of words ending with W is equal to, okay, I am showing it what it is actually. It is like this: F-L-O-E-R-W. That means this position is fixed. Okay, out of these 6 letters, this position of this 6 letter, that is W, is fixed. Now how many letters are remaining? 1, 2, 3, 4, 5. These 5 letters can be arranged in how many ways? Factorial 5 ways. It is just like that. In a class there are 30 students, 20 are boys. How many girls are there? We have to subtract. So here also, without any condition, the letters can be arranged in factorial 6 ways, and with the condition, that is the number of words ending with W is factorial 5. Now how many words are there which are not ending with W? What will do? We shall again subtract. So the number of words not ending with W is equal to how find? We shall definitely subtract factorial 6 minus factorial 5. Now factorial 6 can be written as 6 factorial 5 minus this factorial 5. So 6x minus x is 5x, that is 5 factorial 5. Okay, this 5. This factorial 5 can be arranged or can be written as 5 into 4 into 3 into 2 into 1. Now you see 5 5 is 25, 25 into 4 100. So 3 to just 6, 6 into 100, 600. So the required number of ways is 600. Alright. Now let us read question number 12. How many ways 5 towels can be put into 4 boxes? Before solving it, let us explain. There are 5 towels. Okay. Okay, let us write T1, T2, T3, T4, T5 like this. There are 5 towels. And how many boxes are there? 4 boxes. 1, 2, 3. There are 4 boxes. Now you see, this sum is very simple. Do not get confused. This first towel can be put in any of the boxes 1, 2, 3, 4. So this towel can be arranged as we have discussed. We can put anywhere, that is there are 4 chances. One, either we can put here, again I am explaining, either you can put here or here or here or here. That means this can be arranged in 4 ways. Similarly, this towel can be arranged in how many ways? 1, 2, 3, 4, 4 ways. This can be arranged in 4 ways. This also can be arranged in 4 ways. This can also be arranged in 4 ways. Okay, do not get confused that why we are not taking factorial 4, factorial 4, factorial 4. Not like this, because there is one towel, only one towel that can be arranged, that can be put either here or here or here or here. So we are not considering what is the arrangement of these boxes, arrangement of this towel. This towel can be, actually what we are doing, this towel can be arranged in factorial 4C1 ways, sorry 4P1 ways, 4P1 ways. Okay, that is factory, that is 4 ways. Okay, because there are 4 boxes. Similarly, this towel can be put in any of the boxes. There are 4 boxes, so it can be put in 4 ways. This also can be put in 4 ways. This can be also put in 4 ways. This can also be put in 4 ways. So what is the total number of arrangement? Total number of arrangement is this 4 into 4 into 4 into 4 into 4, or simply 4 to the power 5. Alright, now let us solve it here. First towel can be arranged in 4 ways. Second towel can be arranged in 4 ways. Third towel can be arranged in 4 ways. Similarly, we shall write for all. Fourth towel can be arranged in 4 ways. Fifth towel can be arranged in 4 ways. So what is the total number of arrangement? So total number of arrangement will be the product of all these 4. How many 4 are there? 5. So let us multiply. So this is 4 4 just 16, 16 6 is 256, 256 into 4. So let us multiply. So total number of arrangement equal to 1024. Have you understood this? My beloved students, now let us read question number 13. How many words can be formed with the letters of the word committee? COMMITTEE. This kind of sum we have already done if a letter or object is repeated. Now here, dear students, here let us write total number of arrangement you see here. At first some alphabets or letters are repeated, but at the top what we have to put? Here we have to put the factorial of the total number of alphabets. How many alphabets are there? Let us count. 1 2 3 4 5 6 7 8 9. So here we shall write factorial 9. Then we shall divide by the in factorial we shall write obviously how many alphabets or letters are repeated. 2m factorial 2 into 2t factorial 2. Again this e, there are 2e, so factorial 2. Okay, I am again explaining. There are 9 letters. Those 9 letters can be arranged in factorial 9 ways, divided by the number of individual letters which are repeated. M is repeated twice, so divided by factorial 2. T is repeated twice, so divided by factorial 2. E is repeated twice, so divided by again factorial 2. Let us simplify now. This 9 can be factorial 9 can be written as 9 into 8 1. Okay, factorial 2 can be written as 2 into 1, so this 2 factorial 2 can be written as 2 into 1. This factorial 2 can be written as 2 into 1, that is 2. Now 2 to the 4, 4 to the 8. This can be cancelled. Now let us make group and let us multiply. This is 9 into 7, 63 into this is 30. This is 30 and this is 24. Correct? So let us multiply. At first this and this, 63 into this 24. 1. Okay, these two are multiplied. Then again let us multiply with 30. Let us multiply with 3. Then we will put 0. 4 5 3 6 0. For this 0 we put 0 here. So total number of arrangement, that is, question was how many words can be formed. So here this 45,360 words can be formed. Okay, my beloved students, let us read question number 14. How many ways 10 heads of different colors can be put on the heads of 10 boys sitting in a row so that the red and the black colored heads can never be put on the heads of any two adjacent boys? Here you please try to understand the question. There are 10 boys. There are 10 boys sitting in a single row. Then you have to put heads. How many heads are there? 10 heads are there. But all the colors are not discussed. We have to discuss about this red and black color. Red and black color heads should not be together on the heads of the boys. Okay. Now, as there are 10 boys and 10 heads, so there is no confusion. Let us write 10 heads. Let us write them in a row. 1 2 3 4 5 6 7 8 9 10. Without any condition, these 10 heads can be arranged in how many ways? Factorial 10 ways, right? 10 heads can be arranged in factorial 10 ways. But now they have given us a condition. This red and black, this red color hat and the black color hat, they are so that the red and black color hats can never be together. But if we already discussed that if we get a question that they are never, not ending, not starting, never, then what we take? We take the opposite one. So we will consider that they are together. Then from the total we shall subtract this arrangement. So if red and black colored hats are together, then how many ways this arrangement can be done? Let us count. They are together, mind it please, they are together. Okay, so how many arrangement we can make? You see, let us count. 1 2 3 4 5 6 7 8 9, because they are together. So considering red and black colored hats together, the number of arrangement will be equal to, you see, we have considered that there are 9 factorial 9 ways to do that. How? Let us count again. 1 2 3 4 5 6 7 8, they are together, so factorial 9 ways. But my dear students, this is a red colored hat, this is black colored hat. Opposite thing also can be done, that is this may be black and this may be red. So this red and black color among themselves, or between themselves, we can arrange them in factorial 2 ways, that is into 2 or factorial 2, choice is yours. Now this is the answer of this, considering where red and black colored hats are together. Okay, now but question is something else. Question is red and black color will not be together, so required number of ways will be from the total. From the total is factorial 10, we shall subtract this minus, this is factorial 9 into factorial 2. Okay, now this factorial 10 can be written as 10 factorial 9, this 2 can be written as 2 and 2 into 1, that is 2, and factorial 9. So 10x minus 2x is 8x, that is 8 factorial 9. In the answer I have seen they have not multiplied, they have kept the answer like this. So let us keep the answer like this only. Okay, my beloved student, this is the last question of exercise 6.2. Question number 15. Let us read it. Find the value of n if there are 4 bits. Let us take the first one. The solution is 2 into this 9pn equal to 10pn. Here simple conception is that we shall write like this. What is NPR? NPR is factorial n divided by factorial n minus r. This concept. And one more something we require this also. What is factorial n? Factorial is n into factorial n minus 1, or sometimes n into n minus 1 into factorial n minus 2, like this. Okay, suppose one more thing. Suppose what is 10 minus factorial 10 minus n? This is 10 minus n, then what is the next one? 10 minus 1 is 9, 9 minus n. This conception is required here in all the sums. So this is 2 into what is NPR? N factorial n divided by factorial n minus 9 minus n, and this again NPR, so factorial 10 divided by factorial 10 minus n, n minus r. Okay, this is 2 factorial 9 minus n. Let us expand it here. Factorial 10 can be written as 10 into factorial 9. Okay, this is the conception. And this, suppose here we have already discussed this, luckily we have taken the same example. So factorial 10 minus n is 10 minus n, then factorial 10 minus 1 is 9, 9 minus n. So from both the sides, let us cancel factorial 9 and factorial 9 minus n. So what will be left? 2 is equal to 10 divided by 10 minus n. I repeat, factorial 9 is removed, factorial 9 minus n, factorial 9 minus n is removed. So let us cross multiply. 2 into this, 20 minus twice n is equal to 10. So minus twice n is equal to 10 minus 20, minus twice n is equal to minus 10. So this is n is equal to minus 10 by minus 2. So here we have obtained that n is equal to 5. Is it okay? Now let us move to the second one. Now in the second one, let us take the question. It is, what is given? np5 is 2 means divided by, it is a ratio, np3 is equal to 2 by 1. Same conception we shall use, you can find. So this is NPR, so factorial n divided by factorial n minus 5. Again factorial n divided by factorial n minus 3, n minus 3. So this is 2 by 1. Let us simplify. Suppose it is, sometimes it is 4 by 5, 5 by 6, okay, or 7 by 6. Let us write. How do we simplify? 4 by 5 divided by, so it will be, we will take the reciprocal of this, 6 by 7. So here we shall write like this, factorial n divided by factorial n minus 5 into, we will take the reciprocal of this, factorial n minus 3. Then this is factorial n, this is 2 by 1. Now factorial n cancel. Okay, now here among n minus 3 and n minus 5, which is bigger? Obviously this is bigger, so we'll take the in the decreasing order. So this can be written as n minus 3, n minus 4, then factorial n minus 5. This is factorial n minus 5 divided by 2 by 1. This will get cancelled, so this is n minus 3 into n minus 4 is equal to 2. 2 by 1 is 2. Let us multiply. This is n square minus 4n minus 3n minus minus plus 12, and these two let us bring here. So this is n square minus 7n plus 10 is equal to 0. Okay, now let us, okay, we have to find the value of n. Let us solve by factorization. We can write directly also. So n square, middle term splitting, we have to use here. So this is 5n minus twice n plus 10. You know it, I am not explaining. So let us make a pair. It is n minus 5 minus 2 is common, n minus 5. N minus 5, n minus 2 is equal to 0. So either this is 0 or this is 0, as their product is 0. Either n minus 5 is equal to 0 or n minus 2 equal to 0. N is equal to 5, n is equal to 2. Now out of these two values, one value is wrong. That means we will not accept that value. One value we have to reject. Which value? If we take these two, okay, here 2p5, it is not possible. Always we know that this is either this is equal to this or this is greater than this. So n must be equal to 5 or n must be greater than 5. So we can accept this, but we cannot accept this. Reject it, because the value must be equal to 5 or greater than 5. So therefore n is equal to 5. Is it all right? Now dear students, we have taken number third one, that is 3 into np4 is equal to 5 into n minus 1 p4. Condition is given, n is greater than 4. Now again here same thing, let us express, this is given, we will write in the formula, that is 3 into factorial n, this is np4, so factorial n minus 4. 5 into, what is this? This is npr, so factorial n, here n is n minus 1, then n minus 1 minus 4. So this is 3 into this n, we have to, here we have to cancel this. So this factorial n can be written as n into factorial n minus 1. This is factorial n minus 4. 5 into factorial n minus 1. This is minus 1 minus 4 minus 5. Is it okay? Now you see, this is very simple. 3n factorial n minus 1. This n minus 4. Between n minus 4 and n minus 5, which is greater? This is greater. So this can be written as n minus 4 and factorial n minus 5. 5 factorial n minus 1 factorial n minus 5. From both the side, dear students, you can check that this factorial n minus 1 we can cancel. Similarly, factorial n minus 5 can be cancelled. Okay, so what is left? Here 3n divided by n minus 4, and here 5 is left. Okay, these two are removed, these two are also removed. Now let us cross multiply. This is 3n, this is 5n minus 4 5 is 20. 3n minus 5n minus 20. This is minus twice n minus 20. So here n is equal to this minus 20 divided by minus 2. So in this case n is equal to 10. You see, this answer is, the value of 10 is more than 4. So we can accept this answer. Alright. Now dear students, this is the last one, number 4. Let us write np5 equal to 42 into np3. this can be arranged in factorial n divided by this minus this, that is factorial n minus 5. Again, this is 42, this is factorial n divided by this minus this, n minus 3. Now from both the sides we can remove factorial n. Okay, but between n minus 5 and n minus 3, which is greater? This is greater. Okay, now some of you may have doubt, no, how this is greater. Okay, let us take a value of n which is greater than either 3 or 5. Let us take 6. Okay, so factorial n minus 5 and factorial n minus 3 we want to check. Suppose let us take n is equal to 6. So at 6 minus 5, this n is 6, 6 minus 5 is 1, and this is 6 minus 3, 3. Obviously this is greater. Okay, so this factorial n removed, this is 1, factorial n minus 5, this is 42 because factorial n is removed. Then n minus factorial n minus 3 can be written as n minus 3, next one is n minus 4, next one is n minus 5. So we shall write in factorial. So let us remove factorial n minus 5 from both the sides. So this is 1 by 1, 42 n minus 3 into n minus 4. Let us cross multiply. This into this equal to this into this. So n minus 3 into n minus 4, 42. Okay, let us multiply. N square minus 4n minus 3n plus 12 minus 42 is equal to 0. So this is n square minus this is 7n minus 30 is equal to 0. Okay, 12 minus 42 is 30. Now remaining part let us do here. Okay, now this is n square minus, let us do the middle term splitting. So 30 into 1, 30, 30, 2, 15, 3, 5. Okay, so this 10 minus 3 we can make 7. 10 minus 3 n minus 30 is equal to 0. N square minus this is 10 minus n minus 30 equal to 0. Okay, so this is n square minus 10n minus plus 3n minus 30 is equal to 0. From this and this there are two pair. From this pair n is common, so n minus 10. From here 3 is common, so n minus 10. So this is where what is common between these two? Here n minus 10 is common, so n minus 10 into n plus 3 is equal to 0. So the product is 0. So either this is 0 or this is 0. So either n minus 10 is equal to 0 or n plus 3 is equal to 0. N is equal to 10 and here n is equal to minus 3. This is rejected. We know the value of n is always positive and more than this or equal to this. Okay, so here what is the value of n? N is equal to 10. Dear student, you can check that this n is greater than 4, so we can take n is 10. This value we can accept. Okay, so this is the answer. So thus we have completed exercise 6.2. I hope all of you enjoyed the class. Thank you, students.